Now that we've learned how to derive a demand function, we want to start thinking about how the different variables in our model affect the optimal choice of consumption, affect demand. So that's comparative statics. We want to, holding everything else in our model constant, think about how a change in one variable affects the outcome. And namely, we're going to be interested in thinking about how changes in income and price affect our optimal consumption choices. So we're going to start with income. And everybody's heard of a demand curve, but you probably haven't heard of an Engel curve before. So an Engel curve describes this relationship between income and consumption. So what we want to do is, taking our demand equation, think about what the relationship is between income and our optimal consumption choice. So we're going to just use a generic Cobb-Douglas equation here. So if I have this utility function, right, generic Cobb-Douglas, then I know I'm going to get this demand equation for X, and obviously I'll also get a demand equation for Y, but we'll just focus on X here to start with. So now the question is, what happens to my optimal choice of X as my income changes? And so what we want to do to see that is to take the derivative of our demand equation with respect to income. That will tell me something about how X changes when income changes. So that's pretty easy, right? Because basically, taking the partial derivative, I'm holding all these other variables constant. I've got my alphas and betas, my price, they're all constants, and I just want to take the derivative with respect to I, and there's just an I sitting there. So the derivative is going to be, right, all my constants times basically the derivative of I, which is just 1. And so what I end up with is this equation. Okay, so what does that tell me? It tells me how consumption changes when income changes. So for every 1 unit increase in income, this will be the change in consumption. And one thing that's useful is always to check whether or not this is positive or negative. So we know that if consumption is either increasing or decreasing with income. So here are my alphas, and my betas are always going to be positive. And my price is also going to be positive normally. And so this expression is greater than 0, right? Everything here is positive. So the derivative of consumption with respect to income is positive. What does that tell me? It tells me that this is a normal good, right? What's a normal good? A good that you increase consumption as income increases, right? Increase consumption of X as income increases. All right, so one way to see that on our graph is to plot an income consumption path, right? So now on this graph where I have my indifference curves and my budget constraint, I don't just have good X, I also have good Y. And as I show changes in income, my budget constraint's going to be shifting out, right? Giving me a new optimal consumption bundle of both X and Y for each new level of income. So I can just see where those tangencies are here. And then connecting them gives me this income consumption path, which describes how my optimal consumption bundle changes as income changes. And so basically what we can see based on the income consumption path is the relationship between this change in income and both changes in consumption of X and consumption of Y, right? So I can see right at this lowest level of income, right, I've got X1, Y1, then as income goes up, X increases, Y increases, and so on, both of these goods increase consumption as income increases. So they're both normal goods. Our Cobb-Douglas utility function will always describe normal goods. But obviously not all goods are normal, so I want to show you what this might look like for an inferior product. So here we have another set of budget constraints and indifference curves giving me a backward bending income consumption curve. What does that mean? Let's just plot our income consumption curve here, looking at the tangencies. And you can see why we call it backward bending, right? At first it's increasing and then it kind of bends back. And what's going on here is that we have, for at least a portion of income, X is inferior. And again, you can see that if you see, okay, what's happening as income increases. At first, my consumption of X increases, but then as my income goes up more, I have a decrease in X. X4 would be there. That's kind of messy, but I think you get the idea. So based on this income consumption curve, I could plot the relationship between income and consumption of X, and that is what I would call an Engel curve. So here in this graph, I have I on the y-axis, income, and X on the x-axis. So just exactly what we've done here for different levels of income. At the lowest level of income, I've got X1, and then as my income increases, at first I buy more, but then I buy less. My X4 is here. This should probably be here. Okay, and then my Engel curve, it looks a lot like that income consumption path because I'm talking about the x-axis good here, but you get a sense of what that looks like. So for this portion of income here, X is normal. As income increases, we're increasing consumption. But after this point where it's backward bending here, now X is inferior. As my income increases, I start to consume less of X. And so you can see even for an individual, it's possible to have goods that are normal for some segments of income and inferior for other segments of income. And that makes sense, I think, based on our own experience of consumption. I also want to point out that the Engel curve for Y looks different. Y in this example is not an inferior good. Y is a normal good, and we can see that based on our income consumption path. As our income expands, Y is simply increasing. Our Engel curve for Y would look something like this. Because Y is increasing in income, it's a normal good here for all segments of income. All right, so what we've done here is to describe the relationship between income and consumption. We can look at that using our income consumption path, showing the relationship between income and the optimal consumption bundle, both X and Y. Or if we want to plot an Engel curve, that would just be the relationship between income on the y-axis and one of our consumption goods on the x-axis.